Educator.com. In today's lesson, we're going to cover determinants. And determinants are associated with matrices, and they're useful because they can help you solve problems such as systems of equations. Okay, first of all, defining a determinant. What is a determinant? Every square matrix has a number associated with it called the determinant of the matrix. And notice that this is limited to square matrices, matrices with the same number of rows and columns. And just talking about some convention, when we write a determinant, we use vertical lines like absolute value bars. So for example, if I had a square matrix that was 2 by 2 and I wanted to indicate that I'm talking about the determinant of that matrix, I would write it as such. So again, this is for square matrices only, and use these vertical lines to denote that you're working with the determinant rather than the matrix. Because if I wrote it, so this is the determinant, and if I just use these brackets, then that would actually be the matrix, a 2 by 2 square matrix. All right, starting out, finding determinants of 2 by 2 matrices. Given the matrix with the elements A, B, C, D, the determinant written with these vertical bars A, B, C, D can be found using this formula. And a determinant that's associated with the 2 by 2 matrix is called a second order determinant. So this formula AD minus BC, so you multiply these two elements and then subtract the product of these two elements. So this is pretty straightforward. Let's try an example using a 2 by 2 matrix. So to find this determinant, I'm going to multiply 2 times 3, and from that product I will subtract this product, BC. So I have AD, and I'm going to then find BC, which is 0, negative 1. This equals 6 minus negative 1, which equals 6, and there's negative and negative. That gives me a positive, or 7. Therefore, this determinant, the second order determinant, it's a second order determinant for a 2 by 2 matrix, is 7. Finding the determinant of a 3 by 3 matrix is more complex, and there are a couple of methods. In certain cases, one method works better, in others the other works better, or you may just have a preference for one method over the other. And I'm going to show you both of these methods. And this first one is called expansion by minors. So I'm looking here, and it's asking me for a third order determinant. So it's for a 3 by 3 matrix. So the determinant here is a third order determinant. And one way to find it is to do what's called expansion by minors and break this down into 3 2 by 2 determinants. Once you get, second order determinants. Once you get these second order determinants, we already talked about finding a second order determinant. If you had one that was A, B, C, D, you find that by taking AD and then subtracting the product BC from it. So if I can get these into second order determinants, then it's pretty easy to work with. Now, looking at actually what's happening here is what we did is something called expanding along the first row, expanding along row 1. You can expand along any row, but right here what they did is expanded along row 1. And the reason I know that is I look here and I see A, that's from row 1, B, C. The way you find these minors is to eliminate, you find what you're working with, which is A, and you eliminate the column that A is in and the row that A is in. And that leaves you with E, F, H, I. Okay, looking at what happened here with B. For B, I eliminated the column that B is in, which would be this one, and the row that B is in, which would leave me D, G, Fi right here. For C, eliminate the column that C is in and the row that C is in. And that's going to leave me with this, D, E, G, H. Now, you notice that there's alternating positive and negative signs. And it's important to understand how this works because you can expand along other rows and then you need to know what to make the sign. So it starts out positive. So A is positive, B is negative. Here C is going to be positive, and then you just alternate. Since I was working with A right here, the associated sign is positive. For B, it's negative, and so on. You can actually expand along any row, and you'll see in a little while why you may want to choose another row. You want to pick the row that'll give you the situation that is easiest to work with in terms of finding these determinants and multiplying. If I were to expand along row 2, then I would take whatever's here first, and I would eliminate this column and this row. And then I'd have these 4 things left. Then I would take this second element, I would cross out this column and this row and take what's left, and so on. Let's do an example of expansion by minors. All right, first example, 0, 2, 1, 2, 3, 2, 1, 2, 0. So I need to find this third order determinant using expansion by minors. And I'm going to expand along the first row just to keep it simple like we did up here. Okay, so I start out with the 0, and I know that there's a positive sign associated with that. And I'm going to end up with this, looking for this second order determinant. So 0 is in this first column, so I cross it out in this first row. That's going to leave me with 3, 2, 2, 0. Okay, now, next, just rewriting this, erasing this so I can cross out again. 0, 2, 1. Second section right here is going to be associated with this 2, and it's going to be negative. So negative 2 times this determinant, second order determinant. 2 is in the first row, second column. Cross that out. That's going to leave me with 2, 2, 1, 0. Okay. Next, I've got a 1 here, and there's a positive sign associated with that, so it's plus 1, and that is a second order determinant, and I'm going to find that. Let's reconstruct this. 0, 2, 3, 2. So my 1 is right here in this first column, first row, third column. Cross out the first row and the third column to leave me 2, 3, 1, 2. Okay, now this is much easier to work with. And one thing that's really nice is that there's a 0 here. So what I need to do is find each of these determinants and then multiply them by the scalar that's right, the number that's right out here. Okay. Well, no matter what this turns out to be, I'm multiplying it by 0. So it's just going to drop out. So I'm going to have 0 times something, and it doesn't really matter what it is because it's going to drop out. Then I'm going to have negative 2 times this determinant. So I'm going to find this determinant using AD minus BC. So AD is 2 times 0 minus BC, that's minus 2 times 1. Okay. Plus here's 1 times AB, which is 2 times 2, minus AD minus BC. So I had AD minus BC, minus 3 times 1. Okay. So simplifying this, this is just 0 times whatever was in here. It didn't matter. It's 0. 0 times anything, 0. Minus 2 times 0, 0, minus 2 times 1. Plus 1 times 2 times 2 is 4, minus 3 times 1, which is 3. This equals 0 minus 2 times negative 2 plus 1 times 4 minus 3, which is 1. Okay, now just coming up here to finish this out. This is, get rid of this 0 at this point. This is negative 2 times 2. Negative 2 times negative 2 is 4. 1 times 1 is 1. So this is 5. So at last, we found this third order determinant for this, and it is 5. So just taking it step by step, I expanded along row 1. I found the minor associated with each of these numbers by crossing out the column and the row that that number was in and writing down the 4 numbers that were left, 4 elements that were left. Then I multiplied by 0 for this first one. For the second one, I crossed out row 1, column 2. I was left with 2, 2, 1, 0. Multiplied that by 2, but I made it a negative 2 because of the negative signs associated with this. For the third one, I had 1. I crossed out row 1, column 3. I was left with 2, 3, 1, 2. Multiplied by a positive 1 because there's a positive sign associated with that. Now, I mentioned that you might want to expand along a different row. The best rows to expand along are ones with zeros. And if there had been a row with 2 zeros, I would have expanded along that row. And you see why. I didn't have to do any work here. This is going to drop out. If the second row, for example, would have had 2 zeros, I would have chosen that row. We've done the same method and expanded along row 2. And if I would have had 2 zeros there, great. This drops out, that drops out, only I would have to work with this one. So you choose the row to expand out that has the most zeros because it'll be the easiest one to work with. Okay, so this is one method of finding a third order determinant, and once I get these, I find the second order determinants using what we talked about before, this formula AD minus BC. So I knew the first one is just going to drop out. This second one is right here. It's represented right here. It's negative 2 times AD minus BC. And the third one is 1 times AD minus BC. Then I just did the math to get 5. Now, there's another method we're going to learn today in order to find working with 3 by 3 matrices when you're finding the determinant. And it's called the diagonal method. Using an example to illustrate this, if you need to find this third order determinant and you decide you want to use the diagonal method, the first step is to rewrite the first 2 columns of numbers right next to the determinant. Okay, next to the determinant that you're looking for. So I'm starting out with this, and I'm going to just copy these 2 columns over. So it's 3, negative 1, 0, 1, 2, negative 2. Okay, that's the first step. Next, you begin at the upper left, and you go along the diagonal, going from upper left to down. And you find the sum of the product of the diagonals. So start at upper left and find the sum of the products of the diagonals. Now, what does that mean? It's actually simpler than it sounds. Here I have this first diagonal, 3, 2, 3. I'm going to find that product, 3 times 2 times 3. And then I want to add it to want to find the sum with the next diagonal, starting at the upper left, 1, 4, 0. 1 times 4 times 0. Okay? Then I'm going to add that to the next diagonal, 0, negative 1 times negative 2. Okay. Then you start at the lower left and you find the products of those diagonals and subtract those. Start at lower left and subtract products of the diagonals. Okay, starting at the lower left, I have 0, 2, 0 on this diagonal. So minus 0 times 2 times 0. Okay, next diagonal, I'm going to subtract. Okay, just to make this clearer, let's put it like this. Minus this next diagonal, which is negative 2, 4, and 3. Then I'm going to subtract this next diagonal. 3 times negative 1 times 1. Okay, so all you're going to do is find the products of the diagonals starting up here going down. Find those products, 1, 2, 3, add them. Find the products of these diagonals going up, subtract them. All right, just doing the math. 3 times 2 times 3 is 9 times 2, that's 18. Plus 1 times 4 times 0, 0. Plus 0 times negative 1 times negative 2, 0. Minus 0 times 2 times 0 is 0. Minus negative 2 times 4 is 8, times 3 is negative 24. Minus 3 times negative 1 times 1, so that's just negative 3. Simplifying things a bit, that's 18. Let's get rid of these zeros. We don't need those. And this is minus negative 24, so I'm going to write that as plus 24. Minus negative 3 is plus 3. 18 plus 24 plus 3 is 45. Okay, so if you would have used the other method, expansion by minors, you would have gotten the same result of 45 as this third order determinant. But you need to decide which method you like better and, given the situation, which method seems easier. So again, in order to use diagonals to find this third order determinant, we had to first rewrite the first two columns of numbers right next to the determinant. That allowed us to form sets of diagonals, and we took the downward going diagonals from here, starting up the upper left, going down, and we found the products of each of those and added those. Then we started at the lower left and found the products of those diagonals and subtracted them. Working out that math gave me 45. So that is the third order determinant. Okay. In this first example, we're going to find a second order determinant, and recall that if we have a second order determinant, if we have a second order determinant with elements A, B, C, D, the determinant can be found by multiplying AD, finding that product, and subtracting BC. All right, so doing that right here is going to give me 1 times 4. So 1 times 4 minus B times B times C, which is negative 1. Okay, this equals 4 minus negative 3. If I have a negative and a negative, that gives me a positive. 4 plus 3, so it's 7. So the determinant here is 7 using this formula. So second order determinant, you just need to follow this formula, Pretty straightforward. Third order determinant. I have two choices. I can either use diagonals or I can use expansion of the minors. And I'm actually going to expand, and I'm going to choose which row I should expand along. And recall that I said if you've got zeros, go for that row, because then things cancel out and it makes your life a lot easier. So looking right here, I have a good situation because I actually have two zeros up here in this row. So I'm going to choose to expand along row 1. Now, recall that before we even do anything else, the signs associated would be positive, negative, positive, negative, positive, negative, just so we make sure we're using the right signs for the row we're expanding along. All right, so first I'm going to work with the 0. And it doesn't matter if it's positive or negative because it's a 0, but it would have been positive. Now to find that associated minor, I'm going to cross out the row that it's in and the column that it's in. So row 1, column 1 are gone. That leaves me with 3, 4, 2, 5. Okay, rewriting this just to make it really clear what's happening. Okay, now, next I'm working with this 0. It's a 0, so it doesn't matter, but had it been another number, it would have mattered that this would have been a negative sign associated with it. So right here, I'm going to write a negative. 0. And then I'm going to find the minor associated with it. Okay, the 0 is in row 1, column 2. That leaves me with 2, 4, negative 1, 5. Next, writing this again just so you can see each step. Okay, the next number I'm working with is 1, and that is going to be associated with a plus sign because there's a positive sign right there in that position, times this minor, which is going to be, I'm going to cross out row 1 because that's where the 1 is, and column 3 to leave me with 2, 3, negative 1, 2. 2, 3, negative 1, 2. Okay, so as you can see, these zeros make the math much easier because 0 times whatever this turns out to be is, if I had bothered to find this determinant, it doesn't matter what it is because it's just going to drop out. Same with this one. If I don't know what it is, it doesn't actually matter. Now, I need to find this determinant, and remember that the way I do it is, given that these are the positions, A, B, C, D, I am going to find the product of A and D, and from that, I will subtract the product of B and C. So, this is plus 1 times this. 2 times 2 minus 3 times negative 1. Okay. 3 times negative 1. This is 0, drops out, 0 drops out. All I'm working with is this. 1 times, 2 times 2 is 4, minus 3 times negative 1. That's negative 3, which equals 1 times 4. A negative gives me a positive. So that's 1 times 7, which equals 7. Okay, so in example 2, here we found the third order determinant to be 7, and I did that by expanding the minors along row 1, and I chose row 1 because I saw zeros. So I expanded by eliminating the column and row that 0 was in, the first 0, leaving me 3, 4, 2, 5. And that was associated with a plus. For this next number, it was a 0, and I said there's a negative associated with that and a 0. And then I crossed out the row and the column that 0 was in and was left with 2, 4, negative 1, 5. I wrote those there. For the third element here, which was 1, I said, hey, positives associated with that, so I put plus 1. I crossed out the first row and the third column and was left with 2, 3, negative 1, 2. Then I once I had all this, I had to find these determinants. And then I realized that since I'm multiplying this by 0, I don't need to waste time even finding that. It's just going to drop out. Same with this one. For this one, I use the formula to find this second order determinant, which is AD minus BC. So I have 0, 0 plus 1 times AD, which is 2 times 2, minus 3 times negative 1. Calculated that out to find out that it is 7. The result is 7. Okay, for this third order determinant, I'm going to use the diagonals method. Recall that with the diagonal method, the first thing you need to do is rewrite, so copy over those first 2 columns of numbers right next to the determinant. So you copied those over to expand the array. And then you're going to find the products of the diagonals beginning at the upper left. This diagonal, and this diagonal. And you're going to add those products. Okay, so first I've got 2 times 4 times 1. Then I'm going to add that to the product of this next diagonal, which is 3 times 6 times 0. For the next diagonal, I have 1 times negative 1 times 8. Okay, so that took care of those diagonals. Then I'm going to start at the lower left down here, and I'm going to find the product of those diagonals, and this time I'm going to subtract. So minus 0 times 4 times 1. Then I'm going to subtract this next diagonal, product of this next diagonal, and the product is the product of 8, 6, and 2. Then the next diagonal, subtract that product, which is the product of 1 times negative 1 times 3. Okay, then it's just working out all the arithmetic and making sure that you don't make any errors. 2 times 4 times 1 gives me 8, plus 3 times 6, that is 18. Okay. Then this is, let's see, 1 times negative 1 is negative 1 times 8. That gives me negative 8. Actually, it's 3 times 6 times 0. Correction, that's 0. 3 times 6 times 0, that is 0. This is 1 times negative 1 is negative 1 times 8. That's negative 8. Here, again, I have a 0. It's negative, so this is just going to become 0. Here I have minus 8 times 6, which is 48 times 2. That's going to give me 96. Minus 1 times negative 1 is negative 1 times 3. That's negative 3. Simplifying this a little further, this is 8. Eliminate the 0. Minus 8. Eliminate the 0. Minus 96. And this is minus negative 3, so it's plus 3. 8 minus 8 is 0, so that leaves me with negative 96 plus 3 to give me negative 93. So this determinant is negative 93. And I use the diagonal method, first copying these first 2 columns of numbers right here, then finding the products of the diagonals going from upper left to lower right, and adding those products. Then I went to the lower left, and along those diagonals, I found the products, and I subtracted those, did my arithmetic, and got negative 93 as the determinant. Okay, in example 4, again, I have, I'm looking for a third order determinant, and you could use either method. I'm going to actually expand along row 1. That has a 0 in it, so I'm going to use expansion of the minors. You could have also used row 2 or 3. They all have zeros in them, but these also have smaller numbers. So I'm going to go for row 1. Now, with the expansion of the minors, I want to keep track of my positive and negative signs. So I'm going to start with 0. and that's associated with a positive. And when I expand that, I'm going to eliminate this first column and this first row. And it's going to leave me with 3063. The next, I'm going to rewrite this, 2, 3, 4, so that you can see very clearly. Next number I'm working with is 2, and that's associated with a negative sign. So I'm going to write -2. It's in row 1, column 2. Get rid of those and see that I'm left with 4003. Okay. Next, rewriting this, original. I'm now working with the 3, and that has a positive sign associated with it. So plus 3. Eliminate the row it's in and the column it's in. 4306. Okay, now I have 0 times this determinant. That's just going to be, it's just going to drop out. So I'm not even going to waste my time figuring out that determinant. These other ones, I use AD minus BC to find those. So I have -2 times, this is 4 times 3 minus 0 times 0. Plus, okay, so I have this taken care of, plus 3 times AD minus BC. So that's 4 times 6 minus 0 times 3. Okay, do the math now. This is just 0. It's going to drop out. -2 times 12 minus 0, plus 3 times 24 minus 0. This becomes 0 minus 2 times 12, plus 3 times, this is just 24. Let's get rid of the 0 at this point. -2 times 12 is -24. 3 times 24 is 72. -24 plus 72 equals 48. Okay, so we found this third order determinant by using expansion of the minors along row 1 and being careful to keep the signs straight on the numbers associated with those and crossing out the row and column for each number to find the associated minor. Then once I had those, I saw this first one's just going to drop out. For the second and third, I used AD minus BC to figure this out, multiplied this one by -2 and this one by 3. Working that out gave me 48. So that concludes this session of Educator.com on determinants. I'll see you next lesson.